Okay, we're going to walk through the uh, book's presentation of a binomial option pricing model. The what we have here is in a binomial model we're going to assume that the stock price can take one of two values. This is a simplification of option pricing. The idea is to give you an idea of how it works. It's obviously a lot more complex than this, but we'll see in a little bit how if you add iterations that we can develop a model that can accurately predict and value option pricing. So anyway, so the stock price can either increase by U equals what 1.2. U refers to up, or fall by D, or go down by a multiple of 0.9. So couple things we need to know that they don't bother to show you here. The strike price on our call option, is 110, and the risk-free rate is 10%. That's kind of imperative for this whole analysis. So the current price of the stock, S0, is $100. So this 120 is simply U multiplied by S0, and the 90 is D multiplied by S0. That gives us our upstate and our downstate. The call option is worth $10 in the upstate and 0 in the downstate. So we've got our strike of 110. So this value is simply the 120, the upstate value, minus the strike price. So if this were a put, it would be the strike price minus the value in the low state. So the value of a put in this, if with a strike of 110 in this case, would be 110 minus 90, or 20. So we're going to compare the payoff to one share of stock by borrowing $81.82 at 10%. That's our risk-free rate. So this 81.82 is simply equal to 90 divided by 1 plus the interest rate, or 1.1. That's 81.82, and hopefully that'll make a little more sense as I move forward here. So we're going to borrow this 81.82 and pay 10%. So that's $90 at the end of the year. So the value of the stock is either 90 or 120. So if it's in the downstate, we end up with 0, and in the upstate, we end up with $30. So the payoff in this case is $30. So the outlay is $18.18. That's the difference between the value of a share of stock, 100, minus the 81.82. That's 18.18. So the $18.18 would net us a potential upside payoff of $30 and a downside payoff of 0. So we can hedge this portfolio with 1 share of stock and 3 call options. So stock value, 90 in the downstate, 120 in the upstate. We're going to write the call options to perfectly offset this difference. What we've done is we've created a riskless portfolio. In my mind, this is the book goes about this in a little bit. I think it's a little backward. I prefer to work with the hedge ratio. So in this case, the hedge ratio for a 2-state option is the call option, specifically the call in the upstate minus the call in the downstate, divided by U multiplied by S0, the initial initial stock price, minus the D S0, which is the value of the stock in the down state. So this is simply 10 divided by 0, 10 minus 0 divided by 120 minus 90. So we have 10 divided by 30, which is 1/3, which tells us that we need 1 share of stock and 3 call options to perfectly hedge our portfolio. So take a look at the presentation that I did for the problem. It's actually the way I would work through this problem. So I think it makes a little more sense. Hopefully it does. So we can actually expand this approach. So a single two outcomes is a pretty simplified approach. Simply this example right here, we're adding an additional interval, and then we go down here and we can add a third interval. This is what the probability distribution for a 3 subintervals. It's kind of starting to look like a normal distribution, and this one is for 6 subintervals. So again, it's beginning to look even more like a normal distribution, and then we go to the next one and we get to 20, and it looks a whole lot more like a normal distribution. It's not, but what it tells us is that we can use a normal distribution for the probability distributions, which simplifies the analysis. We'll talk about the normal distribution a little bit more as we talk about, because the Black-Scholes model that we'll talk about next relies on the normal distribution to calculate call and put prices. So, and we'll talk about that more as we go forward.